Alrighty. Since this is basically the last day of new stuff, we just saved the hardest stuff for last. So let's see how we do with it. Okay. Now, what we're going to do is take this region and wrap it around this line. So we're wrapping around a line that's not on the X or Y axis. Maggie, shut your computer. Thank you. All right. So it's pi times the integral from where you start to where you end of the outer axis minus the inner axis. Okay? The outer point minus the inner point. So the shaded region is what we want. So in the end, it's going to be some sort of a three-dimensional thing like this. That looks like that. Okay? So this is kind of hollowed out here. This is hollowed out here. And this is all filled in here. And it's going to be 3 dimensions. Okay? So, now, here's how we got to attack it. This is what we're going around. How far is it to the outer axis? 1. I like it. 1. How far is it to the inner axis? Well, it's constantly changing, right? What's this distance from the purple line down to the blue line? 1 minus sine of x. Boom. All right. So, then this goes from here to here because we're wrapping around something, a horizontal axis. So you use the horizontal axis numbers. So you're going to go 0 to pi, and these are each squared. Then dx. Okay. I'm going to just check on one thing. I'm sure I'm right, but because I'm sure I'm right, I could be totally wrong. But I'm pretty sure. Boom, boom, squared, squared. Yep, that's right. Okay. 8. All right. So, personally, I just put this into my graphing calculator. So if you integrate from 0 to pi of 1 squared minus 1 minus sine x quantity squared, you should get pi times something like 2.49, right? So it's 2.49 pi. 429? Okay. Okay. Let's look at another one. This time we're going to rotate around the line x equals 3. So we're rotating this way around. Okay. Now, we have to do pi, the integral. Since we're rotating around a vertical line, do we use 1 to 3 or do we use 0 to 4? 0 to 4. What is my outer axis distance? Whoa, I have no idea how I did that. What is my outer axis distance? 3 minus 1, right? Because it's an x distance. So it's 2 squared minus the inner axis. Now, the equation of this line is in terms of y. This line is in terms of x. What do I need to do? Solve for x here. So, we have y equals x minus 1 quantity squared. So we're going to take the square root of each side. So the square root of y equals x minus 1. Then we're going to do what? Add 1. So this is the square root of y plus 1. So that's what this line is the square root of y plus 1. So I have to subtract this. So I have to go 3 minus the square root of y plus 1. Well, what is this then? What's 3 minus 1? 3 is this line. How far is it from here to here? You have to subtract. Because this is the square root of y plus 1 line. This is 3. We got to figure out how far this distance is. So 3 minus 1 is 2. And then minus square root of y squared. Okay, we got to figure out this distance here to here. That's 2. You got that, right? That's that one. Then we have to go the inner distance, okay? Because we have the outer distance is there, and then the inner distance constantly changes. So we have to go from here to here. To find this distance, we subtract, because difference in where they are is distance in between. So we subtract 3 minus whatever this line is. If I distribute the negatives, 3 plus a negative 1 is 2 plus a negative y. So then again, put it in your calculator, leave the pi off, and then throw the pi on the end. What do you get, Andrew? 13.33 is 13 and 1/3, which is 40 pi over 3, basically. No, but I think that's what my answer would be. Okay. All right. So that's a couple problems explaining that. Then, we're not done. We're not done. Then we're going to look at some calculator activities. Okay. So a particle moves along the x-axis with a velocity of v sub t equals t squared over sine squared of t plus 2. Particle at position x equals 3. The particle is at position x equals 3 at time equals 2. What's particle at time equals 7? How would we set this up? Well, what's our starting point? 3 is our starting point, plus the integral from what to what? 2 to 7 of t squared over sine squared of t plus 2 dt. And that's how you'd set it up. Throw it in your graph calculator, round to 3 decimal places. Sine, okay, so yeah, you have to go sine of x quantity squared plus 2. Okay? And so here they explain it, but you guys are good, so you guys don't need the whole explanation on that. Okay, so you should get 50.778. The temperature in a room is changing at a rate of r sub t equals ln of t plus 1 sine t degrees Celsius per hour, where t is time in hours. At t equal 1 hour, the temperature is 18 degrees Celsius. What's the room temperature at t equals 3 hours? Well, where do we start at? 18 plus the integral from 1 to 3 of all this, the ln of t plus 1, parentheses, sine of t dt. And then you just change the t's, the x's, And yep, that's what we did here. Same exact thing. Okay, so you'll have some calculator activities there. And then you'll have quiz 3 to take, and then we'll be done. So what are we doing Wednesday? Well, we're reviewing for the Khan Academy test and starting on that. What are we doing Friday? Well, we're reviewing for the AP Classroom test. So then what are we doing next week? Well, Tuesday will be the AP Classroom test, and Thursday will just be a catch-up day. Okay? So that's what's going on next week. Then after Easter, we hit reviewing for the AP test.